Okay, so today what we will do is we will focus on the Solidity fundamentals. So basically, uh, we will look into the basic data types in the Solidity, the both value types and reference types, and then also look into the functions because these are the main part of the contract, the Solidity Ethereum contract. So we'll look at some of the fundamentals into the functions, and also some mutability and other kinds of issues like the visibility, mutability, and when the functions will write to blockchain and all other things. And also, we will try to understand how the transfer of ether happens from one contract to other contract. So we'll try to understand the mechanism behind it, when and how an address can receive ether, if it is called from another smart contract, or if it is called by another account or something like that, right? So what are the things that happen behind the scenes when you actually transfer ether from one contract to other contract? So these are the payable, and also look into some of the fundamentals in the send, receive, ether. Those are the things for today. And what I have planned is, so my plan is to introduce some basic fundamentals in these lectures. Like I will focus more on the programming constructs, like what are the fundamental data types and how you can use them as part of the contracts and things like that. And again, what I will do is I will use Remix IDE. Probably many of you might have heard about Remix. Remix is a online IDE, you can say, for developing smart contracts for Ethereum. Then I will also use a development blockchain. It's called Ganache. So that is a personal blockchain which you can install on your computer. And then what you can do is you can develop the contracts and you can deploy to the Ganache and see how things happen and things like that. And how many of you know about the setup with Remix IDE and Ganache? So, do you have any experience with it, or completely new? It depends upon how much experience you have. Then I will go a bit slow, or skip the things a bit fast. Depends upon that.
The students, you can tell. Professor, I think 50 percentage of the class is quite expert, and remaining
Okay,
50 percentage are novice. So it's a mix.
okay. Okay, so then let's go step by step. And again, please
Yeah.
stop me and put a message in the chat or something like that if you don't understand something, or if you want me to repeat that step and things like that, because I will be changing between slides and Remix IDE and Ganache, so several places. So if you don't get it, then stop me, right? So, and again, another thing is you should be able to run all the code which I show you today. Of course, I have copied the slides to the shared folder. I will also copy the smart contracts which we will use as part of the lecture. So the idea is that you can try them afterwards if you don't have a setup. If you have a setup, you can also try them parallelly and things like that. So that is my basic idea. Just 1 second. Let me copy the smart contract into that folder so that you can, maybe if you have the setup already, then you can also run it, right? So let me put just give me a minute. I will copy the contracts there. Okay, so now I copied the contracts to the folder, so you should be able to see it. Just let me unshare the screen and maybe share it again. Yeah. So if you go to the Dropbox folder, which I shared with you, this is the folder student share. And in that you have the lecture recordings and reading materials and also the slides. Now I created a folder called code, and I copied the contracts, smart contracts into this folder. So if you have a setup, you can run parallelly, but if you don't have setup, maybe you can wait till the lecture and then you can run it later. Okay, and then and what I'm planning to do is, again, let me share these slides. Okay, so what I'm planning to do is this week we'll focus on the fundamentals of the Solidity. We will try to understand all the main things, especially the payable mechanism and how Ether is transferred and other kinds of things. And then the next week or the coming Thursday. And coming Thursday is not a holiday, right? So it's a working day for you. Can we have class on the Thursday as planned, or do you also have the vacation or holidays? So my question is the Thursday, this Thursday is a holiday, or we can could we have the class? Okay, is it a holiday for you on this Thursday? Okay, so I assume that since no one has responded, I assume that it's not a holiday. So then we'll have class on this Thursday. Yeah, we can have class. Okay. Then what we'll do is on Thursday, I will invite some guest lecturer also to help us. And then he will show us how to develop a small application. So again, this is a pet shop application from the Truffle suite. And then we'll put together all the things and try to develop the application. So that is the plan. Okay, first let me explain about the setup, which I will use as part of the lecture and also running the smart contract code and things like that. So Ganache is nothing but it's a personal blockchain. So basically it's a small development environment. So you can download Ganache from here. So they have a pretty good UI. So far, I haven't come across any other UI, any other blockchain with UI, right? So again, there are many development suites for the blockchain, but the main problem is they don't have any user interface. So that means you need to go to the console and you need to run the console interface to see what is the block that is minted and whether the transaction is happened and things like that. On that context, Ganache is quite helpful, even though it doesn't offer the full functionality, but at least you can easily see when you push a contract, when you deploy a contract, whether it has been created, the contract has been deployed to the blockchain or not. It's using a simple interface. So you can download Ganache from this one. And then when the installation is completed, the installation is also easy. It doesn't require any kind of configuration parameters. Just use the default installation. And when you start the Ganache, then it will give an interface like this. It will ask you to whether start Ganache in the quick start mode, which is nothing but some default parameters. So basically, a quick start mode is containing 10 user accounts like this. It will create a default 10 user accounts with each account containing 100 ethers, right? So these are not real ethers, right? So this is a blockchain running on your computer because the Ganache is running on your computer. So it's a small blockchain application emulating the scenario of Ethereum, representing the Ethereum, the functions and things like that. So it's quite convenient for testing and developing the smart contracts and things like that. When you start the Ganache, and then what you can see is you can see the quick start, and when you quick start, then you will get some default options. So with 10 accounts and things like that. And the most important thing is it is running as a server, and it starts offering this RPC server interface at 7545 port on your computer. So that means it will not only run the blockchain on your computer, but also exposes the interface for deploying the smart contracts and then calling the contract functions and things like that. So that is the most important thing. So maybe let me show you how to open Ganache and things like that. So since I have installed, let me just 1 second. So I will open the Ganache and then you can see. Okay, so let me share the screen. So if you install Ganache, it looks like this. When you start, it will ask you to go whether you want to go for quick start or a new workspace. This is also, if you have a TUFL workspace and things like that, then you can go with advanced options, right? But for the simple testing and developing small smart contracts, you can go with quick start. Basically, when you say quick start, it creates default the configuration with some default accounts and some other information, right? So you can see here, it creates accounts. So if you go here, it has only the 0 block, right? So this is the Genesis block. It doesn't have any transactions. So this is the first block and with a block hash and other kinds of things. So since the blockchain had just started, it doesn't have contain any contracts or any blocks, any transactions and things like that. And what it creates is, it creates 10 default accounts. So you can see here, by default, it creates 10 accounts with the addresses the compatible with the Ethereum, the blockchain. And so each address contains 100 Ether, so that you can easily play with the transactions and things like that. And the blocks, accounts and transactions, since we don't have any transactions, we don't have it. But yeah, the contract, somehow it is not working. It only works with the truffle, but don't worry, we can easily use the rest of the things for deployment of the contracts and calling the contract functions, right? So the most important thing is this one. This is a network ID. Just you don't need to worry about it. But this is the URL which we need to care about it, right? So it's running at HTTP and 127.0.0.1, which is nothing but the local host. So this is running in the local computer, and the port is the port at which it listens is 7545. Right, this is the important information, and then we will connect the Remix IDE to the Ganache, right? So that is what we are going to do. So let me switch to the slides. So far, any questions or comments?
Sir, in that slide you have mentioned sandbox environment for testing dApps. Can you please explain about sandbox environment? What is it?
Which one is are you talking about? This one, right? Yeah.
Yeah,
so,
sir.
Yeah. So let me switch to the slides. Okay. Yeah. So yeah, what is sandbox environment, right? So yeah, normally let's say that you are developing these smart contracts in a company, right? So basically you are developing for the for a company and things like that. Then you need to have proper accounts. So for example, wallets, you need to have the crypto wallets. So you will have for example, what is the software which we use, MetaMask or something like that, for creating the wallets and things like that. So that is the real environment, right? A sandbox environment is very simple. So it is called sandbox because it will abstract you from a lot of complexity, right? So in this case, we are using the local blockchain because it's quite simple. Otherwise, what you have to do is, if you are working in a proper company, working in a company environment, probably you will develop the contracts and you will deploy the contracts to the test network of the Ethereum, because these contracts are going to be ending up in the Ethereum, right? So you're developing the contracts and putting them onto the real Ethereum network, and you will play with gas, and you will play with the transaction, transferring money and things like that. So you want to be as compatible with the latest developments as possible. We call it a sandbox environment because it's a very simple emulation of the real setup. Of course, it uses all the functionality or most of the features or the most of the changes in the current Ethereum network and things like that. So, but it's a very, very limited setup, right? So this is a very limited setup. So we use this setup till you get some experience with the smart contracts. But when you get some experience with the smart contracts, and then you will play with the testnet, where you will deploy the contract and test and run them and things like that. So otherwise, it will be too much very hard learning curve, because you need to deal with console. A lot of people are not happy with dealing with console, right? So you need to put commands in the console and then see whether the contracts blocks have been created and things like that. In that sense, this is a very small, tiny environment, which is easy for us to understand and see the things are happening. So this is, let me call it as a beginner's toolkit, right? So for Ethereum and Solidity smart contracts. So in that sense, it is a sandbox environment. Okay, and let's go to the Remix IDE. So Remix, what we will do is, again, Remix, there is a desktop version for Remix. We will focus more on the online version of the Remix IDE. Remix IDE is a very online tool where you can write and compile your smart contracts written in Solidity, right? So that is the main purpose. And they also have a desktop version, but we don't go to the desktop version. The reason is, as part of the lectures, we also plan to use MetaMask, which is a wallet provider, right? So it provides the wallets and all other kinds of things. So, and to integrate the MetaMask, which normally runs in browser and things like that, it's quite difficult to, if you have a local desktop version of the IDE. And I find it very easy to integrate the online Remix IDE and MetaMask, and using the local the blockchain Ganache. Right? So this is the setup which we will use. One important thing about Remix IDE is you just go to remix.ethereum.org. Then it will open a browser page like this, right? So this is where you will write your code, right? So this is where you will write and compile the code and deploy it to the Ganache, and call the functions, and all other things will be happening in this IDE. One important thing to note down is this doesn't have any kind of login, and this Remix IDE don't ask you to create any login accounts or something like that, right? So this is just like you go to an online tool, you do your work, you save your work somewhere on your local computer or on GitHub repository. You can integrate your GitHub repository to the Remix IDE, and then develop the code, and maybe check it, they push it to the GitHub repository, or download the smart contracts files on your local computer and take it as backup, right? Because once you close the browser window, the work will be lost, which is not fully true, right? So what it does is it will use the local storage of the browser. So that means if you again go to the Remix IDE and log Remix IDE and go to the space, probably you will see all your previous work as well, right? But don't rely on the Remix IDE to store your work. It's always your responsibility to download the code and keep it in a safe place. Either it's a GitHub repository of your own, or download it as a zip file and put it onto your computer or something like that, right? So that is the most important part. But if you clear the cache or if you clear the cookies, for example, let's say that if you remove the data from the browser, clean cookies and remove the cookies from the browser, and then it will be like a fresh installation, right? So no work will be saved and things like that. So that is one thing you have to keep in mind. Right, so let me, so what I will do is, I will open the Remix IDE, and then I will connect the Remix IDE to my local Ganache blockchain, right? So because this is smart contracts, what we will do is we will write smart contracts and deploy them and interact with the blockchain and things like that, right? So for that purposes, we need to have a connection. Otherwise, we need to deploy them to some testbed network. Again, you need to use programming to see whether your contract is deployed on the test network or something like that. So that means, again, a lot of JavaScript coding and to do that, right? So that's why I go with a simple setup so that you can get easy experience with developing smart contracts. So what we'll do is we'll open the Remix IDE. And the first step, what we do is we will connect it to our local Ganache, and then if it connects to Ganache, and then we'll start developing some small smart contracts, and then deploy them, and then see what happens in the Ganache when we deploy a contract and things like that. Okay, so let me unshare the screen, and then what I will do is I will let me bring up my. Yes. Okay. So let me share both the Ganache and also the Remix IDE. So, okay. Now you should be able to see both Ganache blockchain and also the Remix IDE, right? So the Remix IDE is nothing but, let me go here. Maybe let me close the window and, okay, so let me. So can you see my browser? You can see my browser, right? Okay, can you see my browser, the Remix IDE?
Yes, pros. Yes,
Okay,
Professor, we can see.
okay. So
Students, are
this
you
is
able to see?
Yes, sir.
Yeah, I think they can.
Yeah. So this is the
Yeah.
Remix IDE. So basically, it contains different tabs and things like that. So, for example, here you have all your code. This is the smart contracts code and things like that. So let me just press this one. You can press start coding. It will create a default contract, right? So hello world contract and things like that. So you write all the Solidity code here. Let me magnify a bit. And then what you do is you will compile it. So this is the compilation, Solidity compiler, and they have different versions. We will see them. And then this is where you deploy by going into this button. Just 1 second. I think it is. Okay, so this is deploy. Yeah. So this is compile, where you can compile your work. So let me take this simple contract, right? So you can see here, we have a hello world contract, nothing much and nothing more and things like that. So let me compile this one. So I go to the Solidity compiler and then say, let me use a old version of the Ethereum compiler, right? So what I will do is I will use 8.18, And the reason is, if you want to push your contracts to local Ganache, I think this is the the latest version. It will work with Ganache. Again, the Ganache is in the archival model. So that means no further development and things like that. So that's why it only supports 8.18 or previous versions of the EVMs in the Ganache. So we'll use 8.18. So then let's see. Yeah, it should be fine. And then we say compile. And it compiles. So it gets green button. So that means it compiled without any problem. So now let us push it to the Ganache, right? So what we will do here is, here we need to do a bit of tricks. So these are the different types of environment to which you can push your smart contracts. So for example, you can see here Remix, VM, Kankan, and Shanghai, and these are the test networks, and these are some of the real networks and some of the test networks and things like that. So for this is main network and other things, but we will focus on this develop Ganache provider. So we go here, and then it will ask us to, with a prompt saying that where is your Ganache blockchain running, right? So I have shown you previously, if you remember clearly, the port number is 7545. So this is the port where it is running, HTTP 127.0.0.1 7545, and then say OK. And then if it connects to the Ganache, then you should see this 557 network, because if I switch to the Ganache, then we have here what we have. So we have the network ID, which is written 5777, right? And the server is running here. If it connects to correctly, then it will say that custom 577 network. So it connected to this network, right? That it means we are connected to the Ganache network. Another way to check it is, I told you before that there are 10 accounts. So if you go here, we have 10 accounts, right? So if it connects to the network, it gets all the account information and populates here. So if you look into here, accounts, if you click here, then you can see all the 10 accounts here, right? So the first account is 2F. So this is the account which contains 2F and C2 and 51. So you can see all these addresses are populated into the Remix ID, right? So then you can choose a particular account, and you can send and receive Ether, and you can do all those things, right? And this is a gas limit. So basically how much gas you want to spend and things like that. And then this is value. This is how we transfer Ether to the contracts. And when you call the contract, or when you call a function on the contract to transfer Ether and things like that. But we will come back to these things later. Now what we'll do is, we will, it says that currently you have no underpinned contracts to interact with. So it says that there are no contracts, right? So what we do is, we will say deploy, press deploy. And then this is the terminal which actually logs information. So you can see here, we get a green button, green tick mark. And let's look into the information here. It says that the transaction hash, the hash value of the transaction, and the block, the hash, and which is, and block number, and the contract address, and from, and true, and things like that, right? So it also gives you how much gas it consumed, because remember, even for deploying the contracts to the blockchain, we need to spend gas. So, and the transaction gas and input and all other things, right? So it shows that the contract deployed successfully, no errors and things like that. Let's move to Ganache and see what happened, right? So let me go to the blocks. Previously, when I shown you the block, so then only 0 block, right? So now we have a new block, and we have a transaction here, and the transaction is contract creation. Since we deployed this hello world transaction to the ganache. So then it created a new block. And again, this is called a sandbox environment. The reason is, in this case, we are developing, we are in the development mode, right? We create contracts and we call contracts and we test contracts as part of the development and things like that. And in a real scenario, a block contains several hundred transactions, right? So a block will be containing several hundred transactions and things like that. In the sandbox environment, or you can say the test scenario, each transaction is a block, because we want to see the immediate results. So we don't wait till you get all these maybe 100 transactions, and then we don't want to wait till it makes a block and things like that. So the ganache works in a mode saying that each transaction is a new block. Whenever you deploy a contract, it will create a block. Whenever you make some state changes, it will create a new transaction, it will create a new block. That's how it works. Right, so here is the information. It uses around 133,135 gas units, and this is the gas limit, and transaction has. And you can see here the same things will be replicated, right? So the gas user is 11335 gas units, and the transaction cost and other information. So if you want the address of the contract, so this is the contract address. So this is the information. Right. So now we connected to the ganache. So our IDE connected to ganache, right? So, and then you can see here, this is also provides a test interface. So if you come here, when you deploy, it will contain the latest contract whichever deployed. So we deployed the Hello World contract. So we go here, and you can see here the contract address, which is nothing but the address of the contract. It's the same 346, and it will also have the same kind of thing, right? And then we have one method called print method. Don't worry, we will go through the methods and how to develop and these things a bit later. But we have one method, and it provided a simple button to call that method, right? So the method, so we just say we will call the method print, and then something happens here. We are in the debug mode, and it called the function on the smart contract, and it got the return value saying that hello world, right? So here, if you see, look into the contract, we are just returning a string saying that hello world, right? So here we called the contract and we got information, things like that. And here, there won't be any changes. The reason is, we will wait for the discussion a bit later. So in this case, what we did is, we didn't do any state changes. So the contract is deployed, then the state change happened. The blockchain contains this new contract. So that's why, that is when the new block is created. The block 1 is created, right? But for calling this function, we didn't make any state changes. We're just returning a value from the function. And so no state changes have been happened. So that means there are no interaction. There is no data written to the blockchain, right? So that's why you don't see any changes in the ganache. But we will go through it a little bit later by looking into what are the state variables, what are the local variables, and these things, right? Okay, so far, do you have any questions or comments? You can unmute your microphone and then put messages or put in the chat or something like that. Any questions or comments, or should I proceed further? Again, this interface looks very confusing when you just started, right? In the beginning, it looks a bit confusing, but remember, this is one of the easiest and a very good entry to the smart contract programming. I have seen the other IDEs which are really, really painful. You have to interact with the console a lot of times and things like that. So that's why this is the simplest and easiest thing which we can easily get started, right? So, and one more thing, maybe when you try the integration between the Ganesh and the online Remix IDE, you might get some problems, depends upon your browser. For example, on my computer, I tried different browsers. I tried Firefox, which works like a charm without any problems. And this Edge, also Microsoft Edge also works fine. I'm running a Mac and it's also running fine. And I tried Brave, Brave browser, but which didn't work out, right? So because the ports were blocked between the communication and things like that. So you might get into some problems if you also have the firewall, local firewall enabled and things like that. So when you have those kinds of problems, disable the firewall and see maybe if it doesn't work with one IDE, try to use if it doesn't work with one browser, try to use another browser to go to the Remix IDE and try to connect it and things like that. Okay, so let me move on to the slides and then we can come back. Okay, so yeah. So we have the Remix IDE set up like this, and now everything should be fine. So now we are ready to develop contracts and deploy to the Ganesh, and then call the contract functions and things like that, right? So that's what the plan is. Let's go to the fundamentals of the Solidity programming. Now we have the environment where we can test this code and things like that. So let's go with that, right? So first of all, what is a Solidity contract? How does it look like? So it looks like this. You have some declarations, you can say pragmas. These are not mainly meant for coding. These are mainly meant for the compiler, right? So, and then you have some contract definition, contract and name of the contract, and you have some variables, right? And these variables, we call them as global variables, or you can say variables with global scope, because they are defined at the contract level. And we will also discuss about where they will be stored and other kinds of things. You have some state data in terms of the variables at the contract level. And then what you have is you have some bunch of functions, right? So these are the units, or these are the functions which contain the business logic. So if you abstract it at a pretty high level, what it contains is contract nothing but contains some data in the form of state and interface to interact with the state, right? So interact with the state and also with the underlying blockchain and things like that. So it contains a bunch of functions and some state information and some pragma, right? So let's go step by step. First of all, let's look into the pragma definition. The reason why I put this slide is you might see the pragma definition on different compilers, different types of declaration and things like that, right? So what is pragma? Pragma is nothing but a line which you contain in the top. So this is a instruction for the compiler, or you can say this is the instruction for the EVM to compile with which EVM versions we want to compile this contract with, right? So this is nothing but saying that, okay, I want my contract to be compiled with a EVM within this range and things like that. So for example, the first example contains pragma solidity greater than 0416, less than 090. So that means what we're saying is this contract, a simple storage contract, we are saying that it should be compiled with the EVM versions greater than 4.16, but less than 090, right? So that is the main information here. And sometimes people will also write like this. This is called hat, you can say, or also it's called cap sometimes. So you might have a declaration saying that like this: pragma solidity hat 0824. What does it mean, right? It means a bit different. It says that the compiled version should be more than 0.0824, but less than 0.090. How can we say that? Because when you have a hat, it means that it should be greater than the specified version, but less than the version which starts with the next integer. So in this case, the next version is 0.090, so it is within that range. So for example, if you have a specification saying that 123, hat 123, that means it should be greater than 123 and less than 200, right? So similarly, if you have 023 and then 030 and things like that. So this is the very standard specification for the instructions to the compilers and things like that. And on the other hand, let's say that if you put a pragma solidity 0162 without any hat or without any is equal to or less than greater than things, then it means that the contract should be only compiled with the version 6.12, right? So 6.12. So that means it cannot be compiled with any other version. This is quite important because the compilers, they look into this, and based on this, they will act whether they can compile with that version or not. Right. So basically, pragmas are common instructions for the compilers, and about how to treat the source code. And pragma 1 is nothing but it's popular in C++, saying that the include code should be only included once and things like that. So okay. Okay, so let's look into the first application. Let's see how far. Okay, so let me quickly deploy this contract, and we will call some functions here, and then we interact, right? So basically, we will compile using this 818, the version, so that we can deploy to the Ganesh, and then we will call the contract functions. So here, what we have is we have two functions, increment and decrement. So basically, we will see what happens in the Ganesh and things like that. So let me again share the those two things. Okay. So let me go to the contract. So I might have the storage contract. Yes, here I have. So let me open the contract. So, oh, not this one. Yeah, this one, counter contract, right? So basically, I have a small contract saying counter, right? So basically, what I have here is I have a simple variable uint256 public count, right? So, and then what I have is I have a function to increment the count. Basically, whenever you call int, then it will increment the count. And I have a function to decrement the count. Whenever you call the dic, it will decrement the count. And I have a function to call the to give the what is the current the count value and things like that, right? So this is the very simple contract. Let me build it and deploy it to the Ganesh, and then we will call different functions and see what happens, right? Remember, notice that we have here a view. We put a view keyword, and we didn't put view keyword here. So I will discuss them a bit later. So first, let us compile the contract. So compile counter.sol. So we will use 8.18. So compile. So compile went without any problems. Then go to the deploy. And we are in the same provider. We don't need to do anything. So we choose one account. So let's say that we go with this account, right? From this account, we are deploying the contract to Ganesh, and we need to spend some gas. So that will be taken from here. Previously, you can see here we have 100 ether for each account. Since we deployed the Hello World contract, the ether has reduced because we spent some gas, right? So, okay, now let us deploy this contract, right? So click deploy. and then you can see that it went good. So you get a green tick, and you can look into here, and then we can see it was deployed into block 2, and this is the contract address, and this is the block hash and the transaction hash, and we can also see how much gas it is spending. So it spent almost 157,000 gas, and that is the transaction cost and things like that, and we don't have any information, right? So that is what we have. Let's switch to the Ganesh, and then let me go to the blocks. So now a new block is created, and why this block is created, if you click here, then you can see here we have a contract creation, right? So we have the contract creation. This is the transaction. This is the transaction hash, and we didn't transfer any ether as part of it. We only paid for the gas to deploy the contract. So that's why we have 0 ether, since we didn't transfer any money. The gas used was this much, and this is the gas price which it used, and yeah, it's mined in the block, and this is the block data or something like that. Right, so the contract is created now, and unfortunately we don't get the contracts here. If we have a TUFL project running on your local TUFL suite, TUFL suite is a bit complicated suite where you can write contracts in Solidity, and you can compile them and things like that. And then you can link the contracts here, and then it will also show the contracts and deployed contracts and things like that. Unfortunately, this is not working, but rest of the things you can easily look into, right? So now let us move on to the this IDE. So now let me test my contract, right? So I deployed this the counter contract, right? So it created some interface for testing the counter contract. So it noticed that the contract was deployed at this address. So you have this address here, and then based on the functions, it will generate some interface to test it, right? So here you have dic and increment, and decrement and increment. We have 2 functions. So for these two functions, it generated this button, right? And there are 2 other functions, count, which we wrote, right? So sorry, this is get, right? So get, we have written the function, so it created a get, and count is a public variable defined in the contract, and for that also it created a button, right? So you can call this one, and so it doesn't create any state change. If it makes a state change, then you have this green tick mark. So this is not a state changing operation, and yeah, it basically gives the value of the count. We didn't assign any value, so by default it has 0, right? So that is one thing. So let's try. You can also call get. Get also is not a state changing operation, so you can see the value of the count is 0, right? So now let me do some things, right? So what I will do is I will increment the count a couple of times. So let's say increment once. I press once. You can see here I get green button, green tick mark. So that means state change has happened. So the block number is 3. You can see here we have created, now a block is created. Let us click it. You can see here now we have the contract call, right? So we are calling the contract, the counter contract, contract, and we called a function on it. So that's why you can see here this has happened, right? And mined in the block, and then you have the transaction data and gas used, gas price, and all other things are noticed here. You can see the same kind of values here also. So that means since we incremented the increment, then it made a state change, right? So that means what is state change? The information is written to the block. Again, let me one more time call this inc one more time. So again, so we pressed inc by 2 times, so that means the counter should be 2. And again, here we have a new block. Basically, since we also made state change in the by calling the inc, so that's why we have Now let me do call the get function, right? So I call the get. Let's see what happens. Then remember, get is not a state change operation, right? Let us discuss how we identify whether state change operation or not. So this is not a state change operation. That's why it is marked with the different colors in the UI. So, and you can see here some information, and you can see here we are calling, we are interested about the value of the count, which is nothing but 2, right? Since we pressed it 2 times, it contains a value 2, right? Any questions or comments so far? There is some comment about what about Chrome. Chrome, I think it should work fine. So yeah. So let's move further. Now what will I do is I will call again this decrement once, and then we will get the data once, and then we will move here, right? Again, decrement it decreases the value of the global variable, which is count. So which is a state changing operation. Don't worry, I will go through systematically what are the variables and where they will be defined if you want to be state change and other kinds of things, just to demoing here. So let's say called decrement, and which is a state changing operation. Then it spends some gas and things like that, and it doesn't get written anything. But here we have a block. Now we have the block 5. Block 4, which is a contract call. So basically, by calling this method, we spend some gas and things like that, right? So, and now what I will do is I will get the value of the count. So I press get, and then see, this is not a state changing operation. Now I have the count as 1, right? So this is how we call the different functions on the contract. Let's switch to the slides. Okay, so this is what we tried. So, okay, let's go step by step, right? So now we are discussing about what type of, what are the different types we have and things like that. So first of all, Solidity is a statically typed language. What does it mean? It's like the C# or Java, you have the static types. So that means the variable must be defined in the beginning, right? So the type of the variable you must define in the beginning, and the typecasting is not permitted. Only on few things you can typecast, but the types definition, they have to be there. And it contains 2 types of types, value types or reference types. So value types, like any other programming language, basically the integers, decimals, and all other basic types, they become the value types. Similar to that, you also have some basic types here. You have int and bytes and other kinds of things as value types. So value types are the basic data types provided by Solidity, and these types of variables are always passed by value. I will talk about it, what is meant by passed by value and passed by reference. So the variables are copied whenever they are used in the function or assignment. So that means it is not the pointer or reference to the variable which is being passed in case of value types. Value types, always the values are copied, right? So that is the main important thing. And most important thing is you have the integers containing different types of integers, right? So ints, you can create an int from 8 to 256 bits. So that means different types of integers are possible. You have Boolean types, which are true and false. You have the fixed point numbers, which are not yet supported in the Solidity. What are the fixed point numbers? The decimal numbers, right? So remember, even now, Ethereum doesn't support decimals. There is no concept of decimal in the Ethereum, right, so far. And there are tricks and hacks to handle decimals. Of course, it's not completely true that we cannot deal with decimals. There are some tricks you can do to deal with the decimals and things like that. but the fixed point numbers is a construct for the decimal numbers to be implemented in the future versions of the compiler, right? Why don't you use decimals? Because decimals consume a lot of memory. In case of normal compilers, for example, C# or Java and other kinds of things, you have good support for decimals and mathematical calculations, but that comes at a cost of, you can say, the resources and RAM and other kinds of things, right? So, so far it doesn't have any decimal types. And it has addresses. These are nothing but the Ethereum addresses, like what we have seen, the addresses created by Ganesh and things like that. And you have bytes, basically sending the code and other kinds of things. So these are the fixed arrays and stuff like that. And unums, enumerations are nothing but how can I say, the labels for a fixed set of numbers. For example, let's say that if you have a weekday as an enumeration, then you have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. These are the enumeration values, right? Which are implemented in any programming language using 0 to 7 or something like that, right? So that is, these are nothing but the labels for integers, predefined integers. And then we have the reference types. So what are the different types? The values of the different types can be modified through the multiple different names as pointers. So let me give you an example. So a reference type is nothing but you can say a pointer to an object, right? In normal programming languages, C# and Java, proper object-oriented languages, you have the reference types as pointers to the objects, right? So that is how they are implemented. And whenever you have a reference type, remember that the values are not copied. In case of reference types, the reference is being sent to, right? So for example, if you have the same variable, let's take a string, right? Strings are reference types in Solidity. If you have a string, and if you pass to a function, and if you make some changes, it will be reflected in even the original string as well, because it's a different type. And which is not the same in the case of value types, because the value types are copied. So that's why there is a difference. Contrast to value types, whenever you get an independent copy of the variable, but here you don't get it, you get a reference. So that's why you have to be careful when you make change. And what are the reference types we have in Solidity? Arrays, which is mostly used, and you have strings and struct, and then you have mapping, which is nothing but a hashable key value pair dictionary. So this is nothing but equivalent to dictionary, but with some limitations and things like that. Okay, so let's see what are the value types we have. Most importantly, you have integers, and you can create integers, and uint is unsigned integers, right from 8-bit to 256-bit. So so that means you can, if you want, you can create a integer containing 34 bits, for example. Then you say that int 34, then it will create a int 34. The reason why we have these many types of integers is to manage the storage space and also the execution environment in a very succinct way, right? Like it allows for creating so many the integer types. And then you have the address. So the address is nothing but a 20-byte value, but on the other hand, which is a Ethereum address. But Solidity and other programming languages, they expose address as an object. We will again discuss that a bit later, because we need to understand the logic behind the addresses and the functionality which is provided by the addresses a bit later. So, but addresses is also a value type. So that means if you pass an address from one to a function and things like that, the values are being copied, right? So that is the most important thing. And you have the fixed site, the byte arrays, which is also a value type. An example for reference type is you have the structures, and you have the arrays, and you have the mapping. All these things are the reference types. For example, here you have a code for the struct. So struct asset, containing one stream name, and which is an array, and then and then we have an address here. So the structure can contain any type of value types or reference types. So this is nothing but a grouping of different objects, right? So this is an example for reference type. Then you have the mapping. Remember, mapping is nothing but a dictionary which contains addresses, which contains some key and value. I think I have a slide here. So mapping is equivalent to a hash map or a dictionary in the regular languages, and maps are created with the syntax. You have the key type and you have the value type. Key type should be any built-in value. Or any contract or bytes and things like that. So there is some limitation for the keys. On the other hand, the value type could be any type, right? So both the built-in value type or it could be a reference type, anything is possible. So you can also have the nested mappings, mapping inside a mapping and things like that. And one more important thing is that mappings are not iterable. For example, in any other programming languages, dictionaries, lists are nothing but iterable. So that means you can go through the iteration, you can loop through them and find out information and things like that. But here we have some kind of limitations. So you need to check for the key and other kinds of things, right? Okay. Okay, so let me see what we have next, and then based on that, we will go through it. Okay, so let's proceed further. Any questions or comments?
No, sir.
Okay, so let's go further, and even if I'm not done today, I will continue in the next class about the discussion. Okay, now we look into the variables, right? So variables, we have the data types. We can create variables, right? And for example, we create a variable like this. So we have the variable name, and remember, Solidity is statically typed checking language. So that means you need to define the what is the type of the variable you are defining, right? And then you have the access modifier. Again, this is a very public variable or private variable and things like that. So this is an example for defining a integer variable, right? So int, public, and this is the name of the variable. And the variables are three different types. So we have local variables, which are declared inside a function. And these local variables, they are not written to the blockchain, right? So they have nothing to do with the blockchain. But we also have the state variables, which are declared outside the function, or you can say which are declared in the scope of a contract. And this is a stateful information. So whenever the contract executes and things like that, this information will be written to the blockchain. And where they are stored, so that means the contract has some kind of the storage, and the information is written to the contract storage. So that's why whenever you have this variable, and whenever you call a function, or you call when you call a function on the smart contract, the information will be written to the blockchain. So that means a transaction will be created. We will discuss a bit more on that. So one more thing is, since it's a statically typed language, in case of Java or C# regular programming languages, you can create a variable with some type. Then what happens is it will be initialized with a null value, right? If you don't put anything, it initializes with null value. And EVM, the Ethereum, the compiler, what it does is, when you declare a variable, it will be assigned to the default value. What is the default value for integer? It's the 0, right? So it has the default value so that it can simplify the execution of the program and things like that. State variables, the values of these variables are permanently stored in the contract storage. Each function has its scope, and the state variable should always be defined outside of the scope. So if you take an example here, this is a variable, state variable, because it is defined in the scope of the contract outside the function call. So uint public state var. So that means we are defining a unsigned integer of 8 bytes with public visibility, and this is the name of the variable. And this is a variable whose information will be written to the blockchain, right? So this is called the state variable. And so we also have the constructors. Let's go further. So then let us discuss what are the local variables. The local variables, first of all, their information is not written to the blockchain. So that is purely local. And what are the local variables? The variables which you define inside the function are called the local variables. So for example, here we have a function, get result, and here we declare 3 variables, local var1, local var2, and result, right? So all these variables are within the scope of the function. And again, remember, the function scope is limited to the execution of the function. What does it mean? Whenever this function is called, then these variables will be initialized as part of the function execution, function call execution. And whenever the function gets execution completed, and all these variables will be thrown away. So the state in the information of these variables is not written anywhere. So that's why we call it as a local variables. So the type of the variable you use to store all the temporary values, especially the EVM, you can say instructions, stack instructions, and things like that. And the last type of variables are called the global variables. These are some special variables that can be used to globally to give information about the transactions and blockchain properties. Let's look into them, what it is. So the global variables, basically, these are the variables which we don't define. These are the variables predefined variable names defined by the environment, or you can say Solidity environment, right? So for example, if you want to find out the hash value of the block, right? So you have the block hash, so that it gives the current the block hash, and Coinbase, block difficulty, the difficulty of the current block, gas limit, and the block number, the number of the block, and things like that. So all this information is provided by the interpreter while executing. And timestamp is another example. When you want to put some information, it will give you the current timestamp. And gas left, how much gas is left, it is integer, and things like that. Most importantly, you will use these global variables. Message.data, it gives the call data which is associated with the call, and message.sender, so this gives the address of the sender who is calling this function. For example, let's say that if you're calling a function from another address, and the callee address is provided as part of message sender, and the signature, sender signature, and the value, this is the most important part. This will have a value. For example, let's say that I'm transferring 2 Ether from my account to a smart contract, right? When I make a call on the smart contract to transfer this money, and I put these 2 Ethers into the value, so the contract, the function, when it gets executed, that will receive this message value as 2 Ethers, because I'm transferring 2 Ethers, right? So that is where you get it. So this always points to the amount of Ether you are transferring explicitly to that contract or to an account or something like that. Remember, this is nothing to do with the gas. Gas is only for making the transaction, happening the transaction on the blockchain, right? So you want to execute the transaction, made it to the blockchain, so that's why you are spending gas. But this is value which is transferring money from one account to other account, right? So that's why it's in the form of V. So 1/12 of Ether or something like that, right? So now timestamp, gas left, and transaction gas price of the gas, and things like that, some other information. Okay. So for example, if you want to find out the, here is an example saying that when we create the contract, we assign the sender's name. So that means the address of the owner who deploy this contract to the blockchain, that will be stored in the ADA, right? So that's the information. So let's take a look at the IDE. So let me share the IDE and Ganesh. Just 1 second, I'm checking for Microsoft Edge. Okay. So let us test some contracts. So for example, go here and let's say primitives. So here, this is a small contract containing different types of variable declarations. So here we have the contract, right? And so here is a bool, that means the Boolean variable, and the visibility, and the name of the variable, and assignment, right? So here is uint, unsigned integer of 8 bits, and unsigned integer of 256 bits, and things like that. And if you don't specify any value, then it is nothing but uint 256, right? So it's a shorthand for if you don't specify anything, it will define it as a 256-bit integer. Yeah, some values here, declaration, and then yeah, here again some more values of declaration. Int ranges from -2 to 225 to +2 to the power of 255. So big value. And yeah, we have some max int and min int specified, and we have the address and things like that. So let's run this one and deploy it and run it. So let me compile this one. Compile and deploy. So go to the deploy, and then yeah, we can take this away. So we want to deploy the primitives contract and deploy. So then it will make a deploy the contract. So we should get it here. Go to the block, and yeah, one transaction, contract creation. So that's why the contract is deployed, and then it provides the interface. So yeah, basically it provides the buttons for all the variables which are public, right? So you can see here several public and public. So that's why it has created, right? Yeah. Ignore about a few things, payable and other kinds of things. We will discuss it later and stuff like that. So, okay. So let us check few things. So what is the max int? Let's call this function. Remember, is it going to be state change or not? Let's see. So it's not, because we are not updating any information. So that's why it's not a state change call. So we are getting the information from here. So what is the value of max int? It is assigned to the maximum value of the int 256. So this is the number which it gives, right? So in essence, you have a very broad range of integers. So you can store pretty big numbers as integers. So the way to handle decimals is also using two integers. One is the integer and one is the divisor or something like you manipulate like this. Since we don't have the floating point support for the in the language and things like that. Similarly, minint, which should give us the same kind of value. So from the minus, so this is also a pretty big number and things like that. So unsigned 256. Yeah. So it's 456. We assigned some value here, right? So yeah, these are the things. Any other interesting things? Default address, let's call it, and it gives us the address. Yeah. So basically, it assigns the default 00 address and things like that. Default boo, what is it? Boolean variable, right? So we are taking the value of the Boolean variables and things like that. So let's see, I have another example. Let me counter hello world. Yeah. So let's continue. Yeah, store and yes. Okay. Let's switch to the slides. Okay. So then we were discussing about the storage, right? So depends upon the variable declaration, the variables will be stored at different locations. They might be either stored on the blockchain, which we call the storage. The variables which are marked storage, they will be written to the blockchain and stored permanently. Their value is written permanently on the blockchain because we cannot delete the data from the blockchain. So the information is always written there. And these are expensive. And some gas is even refunded when the storage is deleted and things like that. But on the other hand, basically these will be written to the how can I say, storage of the smart contract, because these are the values which are stored in the contract and things like that. And whenever you make a changes to the storage, as part, they will be written as part of the transaction and things like that. And we have the other type of the variables, which are called memory. So what does it mean? Remember, these are like variables which are in the local memory, right? So for example, let me take a very crude example comparing with the our computer, right? So in our computer, we have RAM, random access memory, which stores all the information needed for the application processing. So this is where the values are stored when the application is being executed. And then we have the actual storage, hard drive, where information will be written and read from it, right? So in terms of the storage, the blockchain acts as the hard drive, and then the memory is nothing but equivalent to values stored in the RAM. It's a approximate example and things like that. You can have byte arrays of size 32, and they are stored during the function execution. So this information is stored in the EVM memory, right? So as part of the execution. So that's why they also have cost. So you have the gas cost for each variable and things like that. And if the variables are not declared properly, and if you are using as part of the for loop or while loop, it can increase quadratically, right? So the values can it can keep on adding, spending a lot of gas and things like that. And you have the stack variables. These are the cheapest variables manipulated by inline assembly and things like that. So where the variables will be stored. So for example, all the state variables, remember what are the state variables? The variables which are defined in the scope of the contract. They are written to the blockchain, right? So no matter what, if you have a variable at the contract level, they will be stored as part of the contract. So that's why they will be written to blockchain. And function arguments. So for example, if you have a function like this, you have an argument like this, and then they are written, they are stored in the memory of the EVM at the time of execution. And you have the local variables, right? So local variables are the variables defined inside the function. They could be either memory or storage. It depends upon how explicitly you specify, right? So the place needs to be stated explicitly when declaring the variable. So for example, here we have an array called public assets, right? So which is a state variable. And we are also declaring a local variable called asset, which is, we say the storage. So that means this value will be written to the blockchain, right? And at the same time, we also have another function, get using memory, right? And we declare a local variable called asset. Now we we prefix with memory, right? So that means this will be only instantiated in the memory. So that's, but it's not written to the blockchain, right? Which one is costly and expensive? It depends upon really the use case and things like that. So for example, in this simple case, the memory is the memory contains it spends more gas than the storage variable, right? And local variables of the value type. So all the variables which are defined the value types. So for example, integers and bytes and other kinds of things declared inside the function, they are stored on the stack, right? So stack is cheap and easy to handle. So they are stored as part of the EVM execution environment while executing the program. And you also have the constants. So what is a constant? Nothing but you declare the hardcode the values in the constant. So for example, here you hardcode the address of the contract and things like that, or the owner of the contract and things like that. So these are the constants. And then you say that constant with constant keyword, and you have the access, and you have the data type, right? So you declare like this. And you have the immutable. What is immutable? So immutables are defined like this. You have an immutable keyword for your data type name, variable name, and this is the address data type and the public visibility. When you write immutable, you can only instantiate them as part of the constructor, right? So contract has a constructor. So how do you write constructor? You write constructor without any name and other kinds of things, right? Constructors don't have any name. So constructor, and you say, you specify whatever the parameters it needs to pass when you create the instance of the contract, and then you create a constructor, right? If it is immutable, what happens if you don't assign the value in the constructor? You can't change their value. So for example, here you have the the unsigned int, right? This variable, if it is not assigned in the constructor, it will always have the value 0, because I cannot modify the value since it is immutable. I cannot modify the value outside the constructor, so it will always contain the 0. Okay, then let's look into the functions. I think we are running out of time. So should I continue, or maybe 10 minutes more, or what do you think, Professor Shantakumari?
Professor, we can continue. We can finish with this. There's I think 10 minutes. Yeah.
Yeah, let's take 10-15 minutes, and then we will try to finish most of the things. And then again, most of these things will be also repeated during the next class as well, right? Like when we are developing the smart contracts, and we will also do that. Okay, so let's go with the functions, right? So you have a function. So the functions are defined with the function keyword, and you have the name of the function, and you have some parameters, right? And then there are few things when you compare with the function declarations in the other languages, right? You only declare function, name, and visibility, and parameters in the other programming languages. Here it is a bit different. So this is the visibility, right? So this is the visibility, and this is the mutability. We will also discuss what it is mutability and things like that. And you also need to specify what is the types of the information that is written from the function. This is similar to Java and C Sharp, in some versions of the language, you need to specify the return type as well, because it is good for the function declaration and function signature, so the compilers can act upon it. So you also need to specifically say what are the return types. In this case, you are returning two variables. You can return more than one value. The way to more than return one value is just to use a tuple kind of things. You put the braces, then it will create. So it returns one integer and one unsigned integer, right? Okay, so let's look into the visibility. The visibility is this one, right? So, and there are two types of visibilities. You put visibility for the state variables. Remember, what is a state variable? The variables which we declare in the scope of the function, right? In the scope of the, sorry, not function, in the scope of the contract. These are the state variables. And the state variables can be public, internal, or private. Public means allows other contract to read their values. And internal means only the value can be read by the functions defined in the contract, or the contracts derived from this contract. You can have the derived contracts, derived class similar to the parent class and derived class. So the derived contracts can read that one. Private means only access within the contracts. So all the functions can access it, but outside the contract, it is not visible. So this is the state variables. The visibility for the variables which are described in the scope of the contract, right? So function visibility. Function visibility means this is the visibility which we have seen here, right? So it contains external. So that means can be called by other contracts. So this is for the functions, right? So when you say external, it can be called by any other contract, right? Outside contract, visible to outside. If you say internal, then it is only accessible to the defined contract. So that means maybe let me see if we have an example and things like that. Okay, wait for a few minutes. So when I switch to the IDE, I can then also show you. And external means any contract can call them, visible to outside the contract. And then public means, if you say public, the function is public, then both external and internal. So that means it can be contracted by any contract and also local access and things like that. Private is expected. So that means it can only be accessed by the defined contract. Only the function is available for other functions in the contract, not outside. These are easy to understand. And then we have two mutabilities. The mutability type, it contains two values. Either you can say view. What does it mean? When you say a function as view, decorated with the view, with this keyword, it means that it will not modify the state of the blockchain, right? So cannot modify the states or call to other non-view functions. So what does it mean? It can only read the values from the state or the blockchain, but on the other hand, it cannot make any changes. So it cannot return anything to the blockchain. So that's why we call it as view. And when we call it as view, remember when we are testing in the IDE, Remix IDE, sometimes we get this green tick mark where you have spent some gas. And whenever we get green tick mark in the Ganache, you see a block generated. So that means something written to the blockchain, which is written as part of the transaction. A new transaction has arrived and new block has created, right? So that is called non-view. So if a function making changes to the blockchain, then we call it as non-view functions. But if you have a view function, then it can not make any changes to the blockchain, or it can not also call the non-view functions, because non-view functions are the functions which will write to the blockchain. Right? So that is the restriction. And then we also have the pure functions. What is pure functions? Pure functions have no access to the state. So that means they don't read the state, they cannot read the state, and they cannot modify the state as well. So it's a completely pure computational function. let me switch to the IDE to test those things, right? So okay, so we have this payable counter, not payable, the contract, yeah, view pure. So here is my simple contract, right? So basically it contains two functions. So contract view and pure. So it contains one variable. So UN 256, or it could be any 128 as well, right? So, and then, yeah, we don't change it because, okay. So one variable declared at the global scope, declared at the contract level. So this is a state variable, public X, right? And then we have two functions. One is add to X. What does it mean? It will, it contains view setting. So that means it is allowed to read the state, but it is not allowed to change the state. So what is state? State is here, right? So we have the storage at the blockchain level. So this function add to X can read the value of X, and then it will add the value which is sent by us, Y, and it returns the sum of the two values. Then this is an example for pure function. So add function, which takes two values, and we say that is public and pure, and returns an integer, right? So what does it do? It just takes the two numbers which are sent by us, and it will sum up and return it. So it's nothing but doing a computation, right? Which is irrespective of the state changes and things like that. So it doesn't read the state. For example, let's say that if I put like this, X, even it will compile and it will throw error. So the IDE itself identified that, right? So it says that function is declared as pure, but this expression potentially reads from the environment or the state that requires view, right? So that means if I want to get the value of X in this function scope, I cannot have pure, I can only have view, right? If I say view, then it is happy because it says that the function will read the state and things like that. So that's why it is happy. Let me roll back. So that is the pure function, right? So let's run it and then compile it. So compile view pure, okay, and deploy. Let me take this one. So we are deploying the pure function, view and pure. So it has written to the blockchain. Let's check here whether the contract is created. Yes, a new block, which is contract creation. The contract is created and things like that. So it spent almost 596,000 gas. So let's just check it. Yeah, it is the same thing, right? So yeah, transaction cost and gas cost and things like that. Okay, let's now what we will do is we will go back and we will call the functions on it. So you can expand this view on the pure functions. Remember, we have two functions and one global variable with public visibility, right? So this public visibility variable, so that's why you also have the X public visibility, right? So that's why you have the X and add to X and add. So let us try call this X, and then it is not a state change. We are not writing anything in state. So that's why you get this information like a no check mark and things like that. So it gives the value of 1 because X is 1, right? And let us call this add function, which is a pure function, which takes two values. So let's say that maybe I send 5 and 89, two values, and call add. And then it gets here. And remember, here we didn't get any new block, right? So the last block is the contract creation. That's only when we deploy the contract and things like that. Other than that, we didn't get anything, right? So all these function calls, they don't make any changes to the blockchain. So that's why we are not also spending gas, right? So here we have, and then the output is 94. So we send 5 and 89, output is 94. So this is a pure function, which will only meant for computational unit. It doesn't read any kind of state changes. Okay, let's call add to x, right? Because we have an x value, which is 1, and we want to add 8, for example, and then see what happens now. We get a callback, so saying that the input is 8 and the value is 9, right? So here we get that. Let me make some changes to this one, and let's say that it's rather than public, let me say that internal, right? And let us keep x as 105. Yes, some changes. Let's click the compile it and deploy it again. So let me deploy this one. Now it is deployed. So we have a new block. So we should have a new block, transaction, contract creation, and this is the contract created. And now look into the interface, what we have. We only have add and add to x, right? So because our x variable is internal, so this is not publicly readable. So it is not visible outside the contract, right? So that's why it only, it doesn't provide any information. There is no way to read the x now. So let's see if you want to read x value, and let us send some value, and it will give you an out. So let me say that 10. Then let's see what happens. Add to 10, we get a return value 150, right? Because the x value is 105, and we send 10 and we get 150, right? So, and whereas the pure function has no access to the state, so you can send whatever the value you have, 2 and 3, but it doesn't depend anything on the state. Yeah. Any questions or comments? Okay, so let's maybe switch to the let's switch to the slides, and then we will continue for 5 more minutes. Okay, so that is about the mutability, right? So yeah, let us start the discussion on the addresses, and then maybe we'll continue a bit more on the addresses next week, because it needs a bit of understanding when there are different functions on the addresses and things like that. So first of all, the address type in Solidity represents a Ethereum address. So basically it represents a account and address and things like that. It could be the owned account type, or it could be the smart contract address and things like that. All these addresses are represented by addresses. There are 2 types of important distinction between the addresses. So the one is, the one important thing is, like either the address is non-payable address. So that means an address is like a address which doesn't receive any money, right? So that is normal address. Or you can say if the address needs to receive some money, then we call it as address payable, right? So you write address and you say payable, and then it is allowed to receive some ether, right? So it is allowed to receive some ether, it is allowed to receive, transfer ether and send and other kinds of things. So that is the most important thing. So the idea behind this distinction is that the address payable is an address where you can send ether to, while you're not supposed to send Ether to the plain addresses. These might be the addresses of contracts or something like that, right? If the contract is not supposed to receive any Ether, then it will perfectly fine to have the simple address without any payable and for a perfectly function as a smart contract without any issues. And then they support different types of methods and properties. Remember, address is a value type. What does it mean? Whenever you send the address to a function, the values will be copied. It's not a reference, it's copied by value. So, but on the other hand, address is exposed as an object in the Solidity, and it contains information about balance. It will give you the current balance of the Ether it has on it, right? So balance is giving the current balance. Code is associated code and things like that. And you have the code hash, which is also nothing but rather than the code in the form of bytes memory, it gives the hash value, and the code can be downloaded and verified and things like that. All these are a bit advanced functionalities, right? And then you have these important functions: transfer, send, and call. So this is how you send information, you transfer Ether from one account to other account, either using transfer, which takes the amount, and this is called on the address to which the transfer is paid. So, and then you call the transfer, you put the amount, and then it will be transferred. Similarly, you also have the send, which is also used to send Ether, right? This can return exception, but this don't return exception. It only returns true or false value. If the money sent is went without any problems, then you get a true value. Otherwise, you get a false value. And both the transfer and send, they only have a fixed amount of gas. So that means whenever you make these calls, the 2300 is the gas limit, and gas is 2300 is the gas which is spent for these operations, which is a bit riskier sometimes. If you, the reason why is when you transfer money, when you send money, and I will also talk about the other side, what are the things happen, and you might have a bit of more complicated logic on the other side, and which might require a lot of gas, but you only have 2300 gas you specified, so the function made fine, right? So that's why you can also use this function called call. Call has an interesting syntax. You can call and you can pass the code. This is called the call data, you can say. And otherwise, you can simply specify the value and it will transfer the money to the other contract and things like that. And you have different types of calls. So delegate call, and it's a low-level call given to the payload and things like that. You have a static call. So these are the different types of call function you can call it as. Remember one thing, for any function or address, anything to be either receive, if it needs to receive some Ether, right? Then it must be decorated with payable. So this payable is a keyword. You can say decorator, and if you write payable, for example, here address payable public owner, then it means that this address is eligible to receive Ether, right? Even the constructor, you mark it as payable if the contract is supposed to receive some Ether. And if it is a function which can receive some Ether, then also you need to mark this payable, right? So this is the important things to understand. If you don't have the payable as marked on the contract level, the address level, or the constructor level, or the function level, then the contract cannot receive any money. Not only that, there are two other functions which I will talk about in the next class, but let us stop here. So the payable is the most important keyword, which is marked to the addresses and functions to indicate that these functions and these addresses are eligible to receive Ether. So that is the one thing. and let us continue next time. So what I will do next time is I will discuss about what kind of things are happening behind the sending ether and receiving side, right? So when we send ether from one contract or one account to other account, what are the functions that are called, and what are the functions the other contract needs to have to receive ether. So there is a lot of mechanism going on here. We have some special functions like fallback, receive, and yeah, we'll go through this. This needs a bit more explanation and running the contract and showing them and things like that. So, okay, we will continue in the next class from this point. Meanwhile, I would suggest you to try this. I already copied the slides to the shared folder, and try this setup, and try have this ganache, and try all the code examples which I have given, and deploy it and run it. So at least the code examples which we have covered until pure or view functions and things like that, and then we will continue next class. Okay. Any questions or comments?
Yes, Professor. I will also advise the students. Yeah, students, if you have any questions. I think it's very late, Professor, for them.
Yeah.
Yeah.
Good.
Yeah.
So good night, and then
Thank you.
see you
Professor.
on Thursday.
Yeah.
See you on Thursday. Bye.
Thank you, Professor.
Right.